So video 2 is going to help us with the transition into evaluating limits, not by looking at graphs or tables, but by looking at just the function. And in the previous section, we kind of did that with piecewise function. We said if there's an equation given to us, then we can use that formula to calculate the limit. Um, One of the things that you need to put together in your head is the idea that if I have a function that is continuous, that means the graph is approaching some value. Let's say it's approaching 2. And if the limit exists, and if the y value exists and is the same as the limit, well, then there's a point there and everything's connected, right? And so one of the first strategies for evaluating limits algebraically, meaning with just the equation with no graph, no table, is to do direct substitution. Because if we do direct substitution and we get an answer, then that's it. You have the limit value. And so in this first section here, we're going to go ahead and evaluate some of these by just doing direct substitution. So how do you do direct substitution? You just take the function, which is what we did when we were working on those piecewise functions, and then evaluate at the x value that we're approaching. Now remember, the limit is concerned with what happens as I get closer to the x value. But what we're going to do is we're going to check, is there a y value at 3? Because if there is, and I'm dealing with a continuous function, well, then I have my answer for the limit. So the first strategy of evaluating limits is just plug it in and see what you get. 3 squared, that's 9. And if you double 9, this whole thing is 18 minus 3. And we have our first limit value complete. That's it. You're just substituting to see if you get a finite value, a finite number. If you do, then you're done. Let's try this one. 4 to the power of x, but our x value is approaching 0. So let's just plug in 0 and see if we get an answer. And we do. Our answer is 1. That's it. Easy peasy, mac and cheesy. What about C? My formula or my equation is 5. And that's it. That's my limit. Now this one's kind of easy because if you think about it, 5 is just a constant. It's always 5, 5, 5, 5, 5, 5, 5. So as x approaches -2, it's still going to be 5, 5, 5, 5, 5, 5, 5, and that's easy peasy. What about letter D? Let's evaluate and see if we get an answer. So I'm going to substitute whatever x value I'm approaching. Wherever I see a variable x, we're going to substitute this x value. So substitute it here and here and here. And if we get an answer, well, then that's it. Do we get an answer? 1 squared is 1, plus another 1, that's 2, plus another 2, that's 4. And then in the denominator, 1 plus 1 is 2. So yes, we do get a finite answer. That is the limit. And so at the beginning, you're thinking, well, this is going to be easy, right? Like we're just substituting numbers, and then once we get the answer, we're done. So why couldn't we do this before? Like this is pretty straightforward. All right, let's do a trig one. Sine of, and this is pi over 6, what we're approaching. So let's substitute pi over 6. If you read the course description for AP Calculus, whether it's AB or BC, one of the prerequisites is that you have knowledge of the specific special trig values, like sine of pi over 6. So there will be no calculator given. There is no little chart that tells you. You have to know what the value of sine pi over 6 is. If it helps in your head, you can translate pi over 6 into 30 degrees, which it is, and figure out what's the sine of 30 degrees. How you figure that out, College Board says that's up to you. You can use a mental unit circle. You can use the finger test. Whatever way you figure it out, sine of pi over 6 is 1/2. So far, we're doing good. Let's do one last one here in this section. So in order to evaluate this limit, we are going to substitute the value that we're approaching. And we're substituting -2. -2 wherever I saw an x. In the denominator, that's pretty easy to figure out, but something is a little unsettling here because we're going to add negative 2 and 2, and we're going to get 0. And when I substitute it in the numerator, negative 2 to the second power, that's 4. And then minus 3 times negative 2 is plus 6, so that's 10. Plus 1 is 11. What is this? What is 11 divided by 0? Well, 11 divided by 0 is undefined, right? You can't divide by 0. But that is going to tell us something about the type of limit we have. And so the whole purpose of week number 2 in working with limits is to figure out what do we do when we get an answer like we did with the other 5, or when we get a ratio where there's a number that's not 0 on top divided by 0, or if something else happens. So let's pause this video and we'll come back in number 3 to kind of share what happens when we get something weird like that.